Hi all, I am K. Surya, working as assistant professor in the Department of ECE at SNS College of Technology. So in this video, we can see the clipper and its uh, working. So clipper is an electronic circuit that produces an output by removing a part of the input above or below a reference value, which means that the output of the clipper will be the same as that of the input for other than the clipped part. Due to this, the peak-to-peak amplitude of the output of a clipper will be always less than that of the input. So the main advantage of the clipper is that it will eliminate the unwanted noise present in the amplitude of an AC signal. So clippers are classified into two types based on the clipping portion, which is the positive clipper and the negative clipper. So first we'll see about the positive clipper. So the positive clipper will clip only the positive portion of the input signal. So this is a circuit diagram of a positive clipper where a diode is connected to the output of the op amp in the reverse bias condition. And the variable resistors are connected to the output with the help of the plus VCC. So the value of the reference voltage can be chosen by varying the resistor R2. So in the circuit shown above, the sinusoidal voltage signal Vt is applied to the non-inverting terminal of the op amp, and the value of the reference voltage is chosen by varying the resistor R2. So next we'll see the working of the positive clipper. So if the value of the input voltage Vi is less than the value of the reference voltage V reference, then the diode D1 will conduct. So circuit given behaves as a voltage follower. Therefore, the output voltage V naught of the circuit will become the same as the input voltage Vi for Vi less than V reference. If the value of the input voltage is greater than the value of the reference voltage V reference, then the diode will stop conducting and it will go to the off state. Now the op amp operates in the open loop since the feedback path will be open. Therefore, the output voltage V naught of the circuit will be equal to the value of the reference voltage V reference if Vi is greater than V reference. So this is the output waveform shown. So here the V reference can be either set to a positive value or the V reference can be set to the negative value. So for any case, the output will be clipped when for the signal greater than the V reference. And the signal will follow the same as the input if the Vi is less than the V reference. So in the first diagram, V reference is set to the positive value, and in the second diagram, V reference is set as a negative value. So next one is a negative clipper. So the difference between the positive and the negative clipper is that the diode is connected in a reverse manner, and also the reference voltage is connected to minus VEE. So negative clipper is a clipper that clips only the negative portions of the input signal. You can obtain the circuit of the negative clipper just by reversing the diode and taking the reverse polarity of the reference voltage as shown here. So in the circuit, the sinusoidal voltage Vi is applied to the non-inverting terminal of the op amp, and the value of the reference voltage can be chosen by varying the resistor R2. Next, we'll see the working of the negative clipper. So if the value of the input voltage is greater than the reference voltage, then the diode will conduct. So the circuit will act as a voltage follower and the output voltage will be the same as that of the input voltage for the condition Vi is greater than V reference. If the value of the input voltage is less than the value of the reference voltage, then the diode will go to the off state. Then the op amp will operate in the open loop configuration and that will be in the feed since it's connected in the feedback path. Therefore, the output voltage of the circuit will be equal to the reference voltage if Vi is less than V reference. So this is the waveform for negative clipper. So in the first case, your V reference is the negative, and in the second case, your V reference is set to positive. So in both the cases, the portion of the input signal below the V reference value is getting clipped off, and the portion of the input signal above the V reference value will be the same as that of the input. So hope you understood the types of clippers and what is a clipper. Let us take up some assessment questions. So the clipping level in op-amp is determined by the options are AC supply voltage, control voltage, reference voltage, and input voltage. Yes, the answer is reference voltage. So reference voltage always determines the clipping level. In a positive clipper, the diode conducts when the options are Vin is less than V reference, Vin is equal to V reference, Vin is greater than V reference, none of the mentioned. Yes, the answer is Vin is equal to V reference. So when your input value reaches your V reference value, the diode will start to conduct. What happens if the input voltage is higher than the reference voltage in a positive clipper? The options are output voltage is equal to reference voltage, output voltage is equal to DC positive voltage, output voltage is equal to input voltage, and all of them mentioned. As the answer is output voltage is equal to reference voltage. Thank you for watching this video.